Okay, this is Dr. Mitchell again, and we're going to walk through how to do a non-parametric repeated measures ANOVA, or really it's called a Friedman test, where we're looking at non-parametric data, in this case ordinal data, and looking at it in a variety of groups that have these same subjects in these samples. So I'm going to be in my Excel file here. What we have data from middle schoolers, and this is their response on a scale of 1 to 7, 1 being dislike, 1 being like, and the numbers in between being variations of them. How they feel about each of these class subjects: writing, math, science, civics, and PE. And so each subject, so for example, subject in row 2 gave a 3 for writing. They like math a little bit more, so they gave that a 5. Over here at PE, they really love PE, so they gave that a 7. So if we want to know if there's a difference at all between the likability or dislikability of one of these subjects, we would do a repeated measures if we're parametric ANOVA. Well, this is non-parametric data. It's a scale, so we're going to do a Friedman's test. Now, having said that, we're going to analyze this in JASP in a very, very similar way, in fact, almost identical to what we did previously with the repeated measures ANOVA. So I'm going to take my data. I would go to File, Save As, and I'm going to save this as test on my desktop, TEST, again, my CSV file. Then I would immediately go to JASP and import that file. So let's take a look. We'll skip ahead to that. So here's our JASP file. And just like we saw in Excel, there's our class subjects and the response from each subject on the Likert scale. So at this point, we're going to do exactly what we did previously. We'll go up to ANOVA. We're going to choose repeated measures ANOVA. Alrighty. Now what it wants to know is what's your repeated factor? Well, our repeated factor in this is our class subject. Right? Our previous example, it was time. We did things over time, but here the thing we're repeating is class subject. So we're just going to we'll just call it class subject. And then we'll need to begin to enter some of these. So our first one is writing. Our second one is math. And again, we're just going to continue to enter these. Science. All right. This level 4 is civics. Alrighty. Our next one is PE. There we go. Okay. And now I need to tell JASP, okay, which of these columns relates to that class subject. Now, obviously, I just have to match up which subject goes where, and so we'll just real quickly put those in. And as we do that, you'll notice immediately on the right-hand side, it gives us a repeated measures ANOVA table. Again, what we did before when we analyzed parametric data. You'll notice class subjects, sum of squares, degrees of freedom, and all the way on over on the right, it gives us a p-value, and that p-value is less than 0.001. However, this is ordinal data. In fact, if you look when we first pulled the data up, you'll notice if we click on these, it has the ordinal symbol there. So this is ordinal data. So we really shouldn't be using repeated measures ANOVA. We need to use a non-parametric version of this. So in order to do that, we're going to scroll all the way down, and you're going to notice it says non-parametrics. So I'm going to go down to non-parametrics. And what it wants to know is, okay, great. What's the factor? Well, we only have one factor we're repeating, and so that's class subject. So I'll put that in my repeated measure. And you'll notice as we scroll over, it now has done a Friedman test for us. And much like what we saw before, it came up with a value of p is less than 0.001. So there is a significant difference between groups, between these class subjects, as far as likability goes. Now, I'll also tell you, it gives us what's called a Kendall's W, and what this is simply it's a coordinate of relation, basically, where it's telling us, hey, how consistent are the responses in each of these groups? And so it's always a number between 0 and 1. And 0.368 isn't bad, partly because our sample size is a little bit small. So Now, this is great, but again, much like the repeated measures ANOVA, it doesn't tell me what subjects are different. It just tells me there is a difference. So I need to do a post hoc test. So if you'll notice down here on the bottom, it says I can do a Conover's post hoc test, which is just a post hoc test we use with a Friedman's test. I'm going to click on that box, and you'll notice as I move my video across here, immediately I'm going to get a box that has, let's see if I can move this over a little bit. Oh, I guess I can't. I can move that. Hold on. Very touchy. We'll just scroll that over. Immediately what we see is, okay, it's now is going to make post hoc comparisons between each class subject. And I can just go through and look at which p-values are significant. I can use a Bonferroni adjustment or home adjustment, just like we did with repeated measures ANOVA. And you'll notice that some of these are significant. For example, writing and math. That p-value is less than 0.05. Writing and civics, 0.015. I can go down. There's quite a few here that are statistically significant. If I want, I can go back to my analyses here. If I want to do some graphs, some plots, I can do that as well. Put those on a horizontal axis. And immediately there's our graph. I don't know that this works very well with non-parametric data, but again, it's something we can do. So we'll just kind of hide that there. We don't need to look at that right now. If we want, we can look at some descriptive statistics of each of these. And so what that gives me here is what's the mean. Again, not something we would want to know for non-parametric data, but it is there if we, for some reason, wanted to look at that. So again, much like the repeated measures ANOVA, there are some other things here we can look at and assess in regards to this non-parametric data. So this is how we would do a Friedman's test on JASP. Hope this helped, and we'll see you in the next video.